let's put the first program using these functions. We have already studied three parts: the function definition, the function call, and the function declaration. Now let's club all these three things and identify one complete program of function declaration. Let's take up a simple task. I wish to say add two numbers. We don't have any predefined program for a predefined function for addition. Let's put this function called as addition. So now how the program will appear? Your main will now do one part out of these three. So till now your main was indulging into three parts. Your main was reading input, your main was processing the output, and the main was displaying the output. A main used to have three things: input, processing, and output. A part of this particular main has to be now taken outside. Now what is advisable? Whenever they ask you to write a program using functions, without functions, I'll put the entire thing in main, all the three blocks: input block, processing block, and output block. But when I say that I'm supposed to modify this particular code and use or implement functions, some part of main has to be taken outside. Now what part of main will be taken outside? Most oftenly it will be always the processing part which goes outside. So your main will now have two things. Your main will accept the input and the processing part is now outside. So what your main does is, main accepts the values from the user, but it will not do any calculation. These values which have been accepted will now be given to the processing, that is to the function. So the one who is going to read values from the user is main, that is input, gives the value to the processing. The processing will now generate the results. If the results are multiple in nature, then this processing will display the value to the user. That is only when in multiple, when the results are multiple. If the results are multiple, it goes to the user. If the result is single, then the result is given back to the main. So this is single, and this output goes to the user. Follow these path carefully. So the one which goes outside the main is your processing part. So the flow goes in this fashion. Follow these arrows carefully. Follow this. First, the values are going to be accepted from the user, that is the input. This input goes to the processing part. The processing will do a task, and depending upon the result, if it is single, it will give a value back to this particular main, and main interacts with the user. But if the values which are resulting into the processing are multiple, then it gives the values back to the user itself. So you are supposed to always make use of this particular layout when you are designing functions. Let's put a program to illustrate these use of functions. So I'll have a program, a simple program, that is addition of two numbers. Now how to add these two numbers, but this time I'm supposed to use functions for doing this. So I have some instructions written for you, or some instructions we're going to write as during our discussion. So let's avoid this. Let's start with main. I'll have three variables a, b, and c, of which a, b are input and c is the output variable. Clear the screen and then ask the user to enter two numbers. Accept the values from the user. Now here, main is accepting the value from the user. So the value which is read is stored into a and b. It will ask you to enter two numbers. So the first value is read into a and second value is read into b. This a and b are now supposed to be given to a function called as add. So here I am supposed to do addition operation, but not in main but in add. Hence what I'll do is I'll give a call to a function by name add. What need to be added? I need to add a and b. So I'll say add a comma b and a semicolon. So now the value which is there in a goes and gets copied onto x. So from this place the compiler gives a rest to this particular main and now activates the definition. I have two things. One is main and add. As per the rules of C language, your main is the first function which is going to start, irrespective of the number of functions, irrespective of its place where you write. So main starts, gives a call to add. From this it goes outside, copies the value of a onto x, copies the value of b onto y, then does a task int z, z equals to x plus y, return z, and then this goes back. So when it is coming back, it takes a value stored in z. So the function call should now store the result. Hence on the left hand side I'll say c equals to. So the value which goes to this place is now coming back as a result, that is z, and that gets copied onto c. So A and B are copied into X and Y, Z gets copied into C, and then it says sum equals to C. So the instruction which I have written at this place, this we call it as, this is a function call. The one which I have written outside, this is a function definition. This entire thing is a definition, this is your call. Now, when I make a call, we blindly say that this is going to transfer the control to this place. No. In fact, what your system does is, it will check whether the function is called properly or not. Hence, what it does, it makes a comparison. It makes a comparison. ADD add. Yes, you have declared properly. It accepts how many values? 2 values. There are 2 arguments. The first is of type integer. The second is of type integer. What type of value it returns? Integer. So, int. When the function call matches with the declaration, at that time the call goes to the definition. So this instruction is your function prototype or function declaration. This is function prototype. So we have stated function prototype, we have stated function call, and we have stated function definition. In the previous 3 videos, we have dealt with all these 3 things separately. Now it's time to merge them. Recollect the definitions which are wrote, recollect the calls which I've stated, recollect the declarations which I've stated. And here you are going to identify the places where it is supposed to be written. Can I have this definition before main? Yes, you can have. After the header files and before main, you can place this particular definition. But preferably, it is always advisable to write the definitions after this particular main, and the declarations before main and after the header file. Now here, the values of A and B are passed to X and Y. So A and B are called as, I'll write this, A and B are actual arguments, because this is the place where the values are going to move actually from call to definition. Where they get copied? They get copied on X and Y, and X and Y are called as formal arguments. Now how these values are stored in memory? Let me show you the memory. Suppose if A and B are these variables. Now these are the variables which are in main. Now this A gets copied onto, suppose assume that A is 5 and B is say 10. Now this A gets copied onto a variable called as X, and a variable Y receives values from B, 5 and 10. Now X and Y are said to be formal because they are created for add. A and B are created for main. Hence they are called as actual, and function variables which are created for definition, they are called as formal. So I have used X and Y. It means that this X and Y are modifiable. But if I modify X and Y, will they affect A and B? No. Because in memory, they don't have common location. If I put this as border, X and Y are not in the same region or doesn't have the same memory place where A and B are stored. So if I modify X to say 7, it will affect only X but will not affect A. One important rule which we can comment at this place is, when formal arguments are modified, it will not affect the actual arguments. It means that the formal arguments can have the same name. Let me write this definition for one more time. Or, how do I write this definition? Or, I'll say int add int A, comma int B. And here I can write only one instruction, return A plus B. So it means that A and B receives values from A and B. Probably when I spell, I might be spelling the same nomenclature as A and B. But when it comes to system, the first A and B belongs to main and the second A and B belongs to function. So now I can elaborate the statement much more. I can say the values of A and B stored in main are received into values of A and B declared for functions. So formal arguments and actual arguments can share a same name, but they don't have same memory place. So the definition can have only one instruction, that is return. So it means the return can have an expression or a constant. These are some of the things which you're supposed to remember about the definition. So the entire program says function declaration, function call, function definition. A function definition resides outside the main. 2 variables, that is formal arguments with function definition and actual arguments with function call. They can have same name, but they'll never share the same memory. So that is about the concepts of functions. So we have summarized the entire concepts of these functions. So in the later programs, we're going to use the same layout for our functions. Thank you.